So in this problem, we have like this multiplication problem, and we know that A, B, C, and D are different digits. Want to know what is A plus B? So this is, again, a very common type of problem where they might give you a bunch of variables and they might say, oh, maybe a very common variation of this kind of problem. They might say like, ABA plus CD equals CD or something like that. But this is like a very commonly appearing problem. And the strategy for solving these kinds of questions is a lot of the times you want to focus on like which like kind of columns, which columns are like special, right? So what that means here is like, um, if you look at this multiplication problem, let's first look at like this column here, right? A, D, and then D. So just by like how multiplication works, we know this units digit D has to equal A times D, right? So you have to have A times D equal D. So like clearly we immediately get that A equals 1, right? That makes sense if A was 1, because like, right? Because we do D times 1 and we get D, which is like this units digit here, which is good. So if A is 1, then this A here is also 1. So we have like 1B1 times CD has to equal CD. And now, like, let's try to look at this like second to last column here, right? So let's take a look at this column. So more precisely, let's take a look at this like number there. Let's see. So like we already know that A equals 1, right? So our multiplication problem is 1B1 times CD is CD. So if we were to normally do like a multiplication problem, right? If we were to do like a 3-digit number times a 2-digit number, you can kind of think of it as like 1B1 times CD. If we were to do the multiplication, we would get D, B times D, D, and we would have like C, and like B times C, and like C. So this is how like normal multiplication would work. And then we would add these two. So we get D, we have B times D plus C, and then like other stuff over on the left, but we don't care about that. So we see like this digit here has to equal C, right? So we have like B times D plus C has to equal C. So we get like B times D has to equal 0. So like now we kind of have like two possible cases, right? So like we can see that either B equals 0 or D equals 0. So like notice that like if B equals 0, right? Then like we would have like 101 times CD equals CD. So like does this make sense? But like if we were to like just look at like any arbitrary 2-digit number, right? Like this, we can easily verify that this works, right? Like if we had like 101 times like 57 or something, just some random 2-digit number, and we were to multiply it, we get 707 5/5. So if we multiply these, we would get 5757, which indeed works, like 57. Like if you just tried another example, you'd have like maybe 101 times like 99 or something. If we were to multiply, or we can't have the two of the same digits, like 89. If we were to multiply this, we get 909, 808. So we would get 8989, which also works, right? So like we clearly see that like this solution works. We can just let A equal 1 and B equals 0, and we would get 101 times CD equals CD. So we have A equals 1 and B equals 0. So they want A plus B. So the answer would just be A, which is 1.